In this module, we will talk about again the fermenter design. But in this module, we will talk about the construction material. As we have seen in our previous module about the geometrical ratio and the dimension, that about the height and the width. But when we have decided what will be the shape and the size of the fermenter, then the next problem is what will be the material. So that is very critical while talking about the cost of the fermenter. On the other hand, when we talk about, as we have seen in our 13 basic principle of the fermenter design, we have seen that the internal surface of the fermenter should be very smooth, and that we have to run our fermentation for a long time as concerned the aseptic operation and maintaining the containment regulations. So in such cases, the construction material is very critical. And we know that fermentation process can be utilized for 5 different ranges of the fermentation, in which when we are talking about some metabolite production and we are talking about some acid production like citric acid, like formic acid, then the pH have to go down, and sometimes we have to run the fermentation in inclined conditions. So either in case of the sterilization, when we have to increase the temperature, and then we have to use some acidic material just to regulate the pH, then the material of the fermenter is very critical. So we have to focus the 2 points, the cost and the suitable material. So here we will see that there is a different option that can withstand the repeat steam sterilization, because when we say that general organization of the fermentation process, that for the aseptic operation we have to sterilize the fermenter either in situ or ex situ. In case of lab scale fermenter, we have to sterilize ex situ by putting our fermenter inside the autoclave. But in case of a pilot scale and industrial scale, we have to use the in situ sterilization process. So when there will be a heat and we have to be kept in under pressure, and we know that in autoclaving process, either sterilization process, the temperature normally has to raise at 121 degrees Celsius, and the pressure at that point, that is mostly at 15 pound pressure per inch. So there is 2 major options. One is glass and other is stainless steel. So glass is useful because it gives, we know that glass is having a very smooth surface and it is non-toxic, corrosion proof, and it usually easy to examine from the outside. So these are the positive point in glass fermenter. But there is limitation. But we can utilize the glass material only at the lab scale or to some extent with the pilot scale. So when we are talking about the glass vessel, that can be have a round or a flat bottom, and the top that flanged with the carrying plate, because we cannot keep the top plate because there should be different gadgets we have to attach with the top plate. But there is an option. If we want to use the fermenter with the glass material, we can keep the bottom as a round glass. Either we can use a bottom as a stainless and other options. So there is a limitation, because when we want to use the glass for the vessel, then if we have extrude sterilization, and then we can only have the vessel width up to 60 centimeter. But in case of a glass cylinder with stainless steel top and the bottom plates, so these fermenters may be sterilized in situ, but 30 centimeter diameter is the upper size limit to safely withstand the working pressures when we are talking about in situ sterilization, because then there should be a pressure, and sometimes there is a double jacketed wall, because we have to keep the temperature by using the steam, and in that case 30 centimeter diameter is maximum, because that can only withstand that pressure. So that is the limitation when we have to use the glass as a construction material of the vessels. But in later module we will see that what will be the other options.